Eric Burgess here, and we've been told to find the exact trig functions of 420 degrees. Now the wording is a little weird, but what it's asking for is, can we find the sine of 420 degrees? Can we find the cosine, the tangent, the cotangent, the cosecant, the secant, all those things. So first things first, let's find a coterminal angle because 420 degrees is kind of gross. So if we do 420 minus 360, we'll have gone once around a circle and we will be at a coterminal angle. So we're going to do that to get a more reasonable angle. So we see, we get 60 degrees is coterminal. So we can use this instead. Now, 60 degrees means that we've got a triangle that looks something like this. Let's call this 60. Let's call this 30. And let's call this a right angle. So 60 degrees across from that has, now 30, 60, 90 is a special triangle. It has the property that across from 30 we have a 1. Across from 60 we have a radical of 3. And across from the 90 we have a hypotenuse of 2. One of our special triangles. And so from here, we also know that since we have a positive angle of measure, we are in quadrant 1. If I were to draw out the rest of the coordinate system, it would look something like this. And we would be in quadrant 1, in which all these functions will be positive. So we can use this triangle, and we don't have to change any of the signs to adjust for the quadrant we're in. In other words, we don't need to worry about a reference angle. So let's go ahead and figure this out. So sine of 420 degrees is equal to sine's opposite, so that's radical 3 over 2. And now cosecant of 420 degrees is the reciprocal, and I'm going to rationalize at the same time. You would just flip this fraction and then rationalize it. You'll get the same thing. Up next is cosine of, I am covering this up. We don't really need this anymore, so I'm going to just get rid of it. Anyways, as you can see here, we just flip this and then you rationalize it and you'll wind up with this. The 2 will come on top, radical 3 will go down below, multiply top and bottom by rad 3, and you get this. So now we have cosine of 420 degrees. Cosine is adjacent over hypotenuse, which is 2. And that means that the secant of 420 degrees is the reciprocal of that, which is just 2. Tangent of 420 degrees is equal to, and now for tangent, that is rise over run. So that's going to be 3. That's how I think of it. Think of slope over 1 or just rad 3. And cotangent of 420 degrees is x over y, or run over rise. That's going to be equal to, let's look at this carefully. Okay, so it would be 1 over rad 3. I don't know why I have a hard time doing this one in my head, but for whatever reason I do. So we're going to have rad 3 over 3. It would be the cotangent of this, if you were to rationalize this denominator. So all I did was flip this and then rationalize it. And as you can see, sometimes if it doesn't come right to you, it's okay. Just write out the middle steps and you'll see it. So these are our answers. So all you need to do is figure out, what kind of a triangle are we using here? Is it a special triangle where we could take advantage of some things that we already know about it? And then using those things, we can go ahead and determine the trig functions. If you have any questions, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.